The next thing we're going to look at is how to output results from the simulation. This functionality is in the standalone program, but it's not written into the online version as it is. But you can add it yourself if you want, and I'll talk you through that at the end of this session. So we've already seen that at the end of the run, the simulation will tell you how many people were infected and what proportion of the population that is. The code that makes it do that is down here, right at the end, these lines here. The command here is this, write ln. That's L, not I or 1 or anything like that. The write bit is hopefully fairly obvious. We want the computer to write something. In fact, it will write whatever you tell it to, specifically the stuff in the brackets here. The ln bit, that's for line. What that means is that when it is finished writing what you've told it to, it will start a new line. Remember, we can use curly brackets to get the computer to ignore things that are written in the code. We used that earlier on for leaving ourselves comments. For now, let's make it ignore these lines here and versions. So, essentially all we're going to do is we're going to copy the syntax of what is already written. So we're going to make our own version of it. So we're going to go write ln, then open bracket. And I'm going to start with an open quote because that's what the other version had. And we're going to write hello world. You can write exactly what you fancy. And then we're going to close bracket. And I'm going to end it with a semicolon. To get it to write text verbatim, so exactly letter for letter what you've written, you need to use these single quotation marks like we've got here. So we want to run this. To make sure it runs fairly quickly, I'm going to change some of the numbers up here. Remember what we do with those. And let's run that and see what happens. So it's running. There's one left. And it's gone. Okay, and here we go. In our output, we now have hello world. Very nice. So that's sort of it really. That's how to make it output stuff. Let's go back to the real code and see if we can understand what's going on here. So let's get rid of that and get rid of the curly brackets and have a bit of a deeper dig into what's going on here. So first up, we've got this write ln, open bracket, lovely. Then an open quote mark, some text, total infected overall, colon, space, close quote. So that will get reproduced exactly as it is. Then we've got this little plus sign. So we know we want to add on an extra bit in our output. And that bit we're going to add is this, str brackets num infected. Str usually stands for string, and that sort of just means a bit of output, really. So that next bit of output is this thing here, called num infected. As the name suggests, this is the number of people that have been infected. For now, we won't worry exactly how or where it's calculated, but essentially it's a tally. And each time the simulation infects a new person, 1 is added to this tally. So the output of this is the number of people infected. Then we've got another plus, so we're adding another bit, and this time we're adding a bit of text, a space and an open bracket. So that's printed as it is. The next part is a little bit more complicated. So we've got another plus, then we've got this QSTR. Essentially, we're going to get the computer to do some maths for us. That's what happens in this QSTR thing. Inside this bracket here, there are 3 things separated by commas. The computer is going to take the first one, is going to divide it by the second one, and then this third number here, that's the number of decimal places that it's going to show us. In this case, time is the length of time that the simulation has been running for. However, the computer counts it in milliseconds, so if we want it in seconds, then we need to divide by 1,000. And finally, it's going to give us the answer to 2 decimal places. Good. We close that bracket, we have a plus, and then we have some more stuff in quotation marks. So we're closing out with this space, sec, close bracket, close quotation mark. Then we close this bracket here to match the one at the beginning for our right ln. And then at the very end, we colon. That's so that the computer knows we've got to the end of that command and that it should expect another command coming along on the next line. This one here. And that's it. That's our output written. Let's just quickly run it again to see that output in action. Here it is. Total infected overall, number infected, open bracket, time in milliseconds divided by 1,000, 2 decimal places, then we close with a sec and a close bracket, and we start a new line. So let's see if we can understand the next line by using what we've just gone through. So we start out the same, right ln, open bracket, open quote, proportion infected. Then we've got a big long gap of spaces here. Essentially that helps our output to line up nicely. Every character, so every letter or every number in the output, takes up the same width. So you can make things line up very nicely by putting in spaces. It's that simple. Then we have another one of these Q-stra sums. So it's the first part divided by the second part, and then the third part is the number of decimal places. So we've got the number of people who are infected times 100 divided by width times height minus the number of people who are immune. What does that mean? Well, this times 100 is straightforward. That's just because we want a percentage eventually. You can see our little percent sign at the end here. So we times by 100 to make sure that what we're getting out is a percent. Now you'd think if you want the proportion infected overall, you would take the number infected and you'd divide by the total population. So number infected, num infected. Then here, the width and the height. The width and the height refer to the 100 by 100 grid, our canvas over here, our grid, where each cell represents a person in our population. So the width times the height is the size of our population. In this case, 100 by 100 gives 10,000. However, we've also got this minus num immune here. Now, num immune is the count of how many people at the start were designated as being already immune to the disease. So remember, that was something we set up here. We could set our immune probability to whatever value we wanted. And that was how likely someone, a cell, in our simulation would be to be immune before the disease starts to spread. So actually, this sum here is not calculating the overall proportion of the population that gets infected, but the proportion of the susceptible population that gets infected. Let's see if we can illustrate that. So let's set the immune probability to 99. So a person is 99% likely to already be immune to this disease. Then let's run the simulation and see what we get. Just a few cases in the centre. And we can see that we got 5 cases overall. 5 cases in 10,000 people is not 5%, it's 0.05%. So this is not 5% of our overall population that got infected. With an immune probability of 99%, only approximately 1% were going to be susceptible. So what we've got is 5 cases out of a susceptible population of about 100. 5 in about 100 is about 5%. So that's what this calculation at the end is actually doing. Of course, you have the power to change it if you want. If that's not the number you want it to output, make it output something else. Now, if the fiddly little screen under the canvas here is irritating you, then you can always click here where it says output, and that is where all of the text appears. And finally, if you're using the online version, essentially you can just use commands like those we've been looking at at the end of the program. So at the moment there's nothing there, but just change it, put them in for yourself. Now in fact the tallies are set up slightly differently in the online version. So numinfected actually counts the number of people who are currently infected, which in the other version was numinfectious, rather than the number of people who have been infected overall. So although outputting works in the same way whichever system you're on, in the online system you don't currently have the right variables set up to get exactly the same output as the standalone program. But that's something we'll get to very soon, and in the meantime you can make it output whatever you want. So if you want something down at the end here, let's put a semicolon there, and then we can just write the command. Write ln, open bracket, bye.